Hello everyone, today we are going to talk about decision tree algorithms, which is a part of supervised learning. We all know that supervised learning are of two types, classification and regression, and decision tree algorithms can work for both classification and regression. Starting with the definition of decision tree, a decision tree is a graphical representation of specific decision situations that are used when complex branching occurs in a structured decision process. A decision tree is a predictive model based on branching series of Boolean tests that use specific facts to make more generalized conclusions. A decision tree is a simple representation for classifying examples. It is a supervised machine learning where the data is continuously split according to a certain parameter. We will talk about what decision tree consists of. It consists of nodes, branches, and leaf nodes. What are nodes? These are the tests for the value of a certain attribute. When we talk about the branches or the edges, it corresponds to the outcome of a test and connect to the next node or leaf. When we talk about the leaf nodes, these are the terminal nodes that predict the outcome. It usually represents class labels or class distribution. In the diagram that we have, we can clearly see the leaf nodes, branches, and edges. And here this is known as the root node. Why root node? Is because this is the first node from where the decision tree starts. Moving further, we will talk about the example of decision tree. Let's say that we want to predict whether a person is fit or unfit, and we have their information like their ages, their eating habits or physical activity, etc. Now the problem is whether the person is fit or not. For that we have a root node over here which tests whether the age of the person is less than 30 or not. If it says yes, then we have a certain different type of nodes and different questions, and if it says no, again we have different questions for that. So these questions or these nodes are actually known as branches or edges. Why? Because this connects the earlier node to the next node, and therefore these are known as branches. So eats a lot of pizzas and exercise in the morning will again have two different answers. They are yes or no. So if it is yes for eating lots of pizzas, the person is unfit, and if it is no for that, the person is fit. Similarly, whether the person exercises in the morning, if it is yes, then the person is fit. If it is no, the person is unfit. Fit and unfit are actually the decisions that are made by the decision tree, and these are known as the leaf nodes. Why leaf node? Is because in a decision tree, the end point where the decision is occurred are known as the leaf nodes. Moving to the next slide, we have different types. These are the classification and regression. When we talk about the classification, we have seen in the above example, which is actually an example of classification, where the outcome was a variable like fit or unfit. The decision variables is categorical or discrete. Such a tree is built through a process known as binary recursive partitioning. This is an iterative process of splitting the data into partitions and then splitting it up further on each of the branches. When we talk about regression, the decision trees where the target variable can take continuous values, typically real numbers, are called regression trees. For example, we have the price of a house or a patient's length of a stay in the hospital. So when we have the example for the price of a house, the price of the house can never be only 10 lakh, 15 lakh or 20 lakh. It can be more than that or less than that. We cannot predict that. Now moving on to the examples in classification and regression. So this is a decision tree in classification. Again we have a root node and the branches, and these are the leaf nodes that we have, which are actually providing with the decision whether the person is a male or female. Similarly, when we talk about the regression problems, we have a bit different decision tree. Here this is again a root node, and when we are talking about the decisions made or about the leaf node, we have a graph over here. So when it is 18, that means y is equal to 18. This is the region where it actually lies. When it is 22, again we have this region. For 20, we have this region, and for 27, this respectively. Moving on to the applications of decision tree algorithms to achieve an objective such as a maximum profit or optimize cost. When there are several courses of action, there is a calculable measure of benefit of various alternatives. When there are events beyond the control of decision makers, like environmental factors, decision tree algorithms are used. Uncertainty concerning which outcome will actually happen, these all applications are actually performed by decision tree algorithms. At the end, we will discuss today's presentation's summary. A decision tree is a graphical representation of specific decision situations that are used when complex branching occurs in a structured decision process. Decision tree consists of nodes, edges, and leaf nodes. There are two types of decision trees: classification and regression. Thank you so much. If you liked our video and would like to recommend it to your friends, please like, share, and subscribe to Indeed Inspiring Infotech. We would also love to hear your suggestions and feedback in the comment section below.